We're starting Unit 2, and we're going to start with functions and relations. So a relation is just when you have an x and a y paired together. So first, let's just talk about, it's kind of a review of how you put points together. So here, how you make a mapping. If we have let's say these are like our x's, these are like our y's. So here, each x points to its y partner. So you have here, if I wanted to list the points that this mapping represents, I have 9 and follow the arrow, it's paired with 5. And then -2. Normally you see the x's listed least to greatest. This one's not, but that's fine. -2 is also paired with 5. You see how 5 got arrows from two different things, numbers. Then 3 actually happens twice. He's got 2 arrows. He's paired with 2 different y's. 3 is paired with -1, and then 3 is paired with +1. So these points are represented by this mapping. So let's look at this table here. And let's see if we could put it in the mapping. You see how the x's are on the top here and the bottom here. This column has the x's and y's listed vertically. Now don't worry about this, we're going to learn it tomorrow. It just means y. So let's take this first table. Let's list, let me see if I want to do that. Yeah, that's fine. List your x's, 0, 1, 2, 3, 4. And then pair them with their y's. Let's list our y's least to greatest. Well, they already are listed least to greatest. Even if they weren't, that's how you would do it. So 0's paired to -7, 1 to 0, 2 to 7, 3 to 14, 4 to 21. Let's say, just for fun, that there was an extra column here that had a 1 paired to one of these other numbers. Then you wouldn't write the 1 twice. You would just draw an arrow. It already has an arrow to 0. Now I'm going to make another arrow to the 14. Because that's the way a mapping works. You don't list the number twice. You only list them once in the x's. See, this would be my x's. This would be my y's. Once in the y's. And then the arrows are what tells you that they're paired together. So here, I'm not going to make a mapping out of this one. I'm just going to list it. Let's say this would be 110, this would be 322, this would be 534, 746, and 958. It's just a relation. That means your x and your y are paired and go together. All right. We have a graph. Hopefully, we've done this since 5th grade, so hopefully we're good at plotting points and reading them. So point A here, we do our x first, then y. It is at the point -2, -3. Point B is at -4, -2. Point C is at 1, 6. And point D is at -3, +3. We'll just leave it like that. And then you have a list here of x's and y's. We could make a table out of this. Let's make a mapping out of it, because those seem to be the ones y'all have the most trouble with. Let's put our x's here and our y's here. So you want to list your x's least to greatest. So we're going to go, what's the smallest x? -4. Then 0, then 3, then 5. Now I'm going to list my y's least to greatest. -5, 0, 2, 7. Now I'm going to draw my arrows. Let's start with 3. 3 is paired with 0. -4 is paired with 2. 0 is paired with -5. And 5 is paired with 7. Those are relations and the different ways you might see them. A mapping, a table, a graph, an ordered pair. So then what we're going to do is we're going to learn the difference between a relation. So a relation is, I'm just going to say X's and Y's paired together. So you've got X's paired with Y's. It's just a group of partners, basically. It's X and Y have a relationship. They're paired together. Now, a function is a relation. It's just a special kind of relation. So a function is a relation in which each X, or we also call that input, is paired with exactly one unique Y. Each X is paired with exactly one unique Y. So if you look back at what we just did, do you see how this X had only one Y, this X had only one Y, but do you see how this X was paired with two different Y's? It's not a function. So the way to tell whether something's a function is, does every X have one and only one Y it can be paired with? So let's skip over here. You can tell if ordered pairs are a function. So if the X and Y is in each one, it's a relation. But if X is repeated, it's not a function. So my shortcut I always say is X can't repeat. X can't be paired with more than one Y. It can't repeat, or it's not a function. So we haven't learned domain and range yet, so we're skipping this. Function. Let's look at what a function would look like. It might have 0, 5, 2, 4. This thing's in the way. Relations are shown with a little bracket, squiggly bracket. That's how you know they go together. If you can't draw a bracket, then draw a squiggle. Let's say we have 5, 4, and 6, -7, 8, 0. Just making up some. Does X repeat? No. All the X's are different, so it is a function. Now, do you notice how Y repeats? I had 2 4s. That's okay. I don't care what Y does. I only care if X repeats. And if X repeats, it's not a function. Okay, so not a function would be like 0, 5, 1, 3, 1, 8, 4, -6. Do you see how X repeated? The 1 happened twice and had 2 different Y partners. So that means it's not a function. All right, let's go down here to a table. Same thing in the table. If it is a function, X's aren't going to repeat. So each X is only going to have one Y with it. It's not going to repeat. If it's not a function, so do you see how the 0 happened twice? 0 happened twice with 2 different x's. Therefore, it is not a function because of this. Now, 1 and -1 are totally different numbers. It's okay. The zeros repeating is the problem there. All right, so this is supposed to be a mapping. So let's put them in their little maps. Input, output. X is your input, Y is your output. So let's say that this 4 is paired with a 2. The 3 is paired with an 8. The -2 is paired with a -7, and 10 with 11. All right, we think of this as the Indians are hunting the buffalo. Each Indian can only shoot one buffalo at a time. The Indians can't shoot more than one arrow in 2 different directions at the same time. So if each Indian is only shooting one buffalo, if each input is only matched with one distinct output, it's a function. But what if, let's see, this Indian has his buffalo, this Indian has his buffalo, this Indian shoots this buffalo and this buffalo, this one here. Well, that's not possible. He's not that talented. He can't shoot 2 different arrows at 2 different buffalo at the same time. So this is not a function if there's this 4, that one of the input values has 2 different outputs, not a function. All right. The last thing is we can use the vertical line test. Now, I didn't put a little graph here for you, so you're going to have to do a little work here and draw your own XY graph. Now, vertical line test is a real quick and easy way to tell if a graph is a function. Because if X doesn't repeat, if it's a function and X doesn't repeat, then if you did like the pencil test, you put a pencil through it vertically. We call it the vertical line test. If a vertical line, any vertical line you draw anywhere, only goes through that graph once, then it's a function. So you can kind of see, I'm going to draw another one on here. You see this one, a vertical line only goes through it once, anywhere you drew it. Now, it's not a function if anywhere you drew a line, it would go through that graph, hit that graph more than once. That means X is repeating. That means that X has more than one Y value associated with it. So it's not a function if the vertical line hits it more than once. Let's see. This would be the example, an example of not a function, because do you see how it hit it more than once? Right there. So X can't repeat. That's your test for determining if a relation is a function or not.